In this video, we examine the tragic crash of Air India Flight 171, a Boeing 787 Dreamliner flying from India to England. While details are still emerging, we've reviewed much of the publicly available footage and initial reports. As of this recording, no ATC recordings have been released, since India does not currently allow public access to its ATC audio. That said, with the video footage that shows the aircraft from the beginning of its takeoff roll to the moment of impact and some background knowledge, we can begin to ask critical questions that may help explain what went wrong. The first question is whether the aircraft used the entire runway to complete its takeoff roll. In this footage, as the aircraft becomes airborne, there appears to be a cloud of smoke or dust beneath it. This raises concerns. Did the aircraft overrun the paved portion of the runway? Was this smoke caused by engine trouble, tire contact with non-paved surfaces, or something else entirely? While there have been no reports confirming any engine issues, the visible dust or smoke coming from the left side of the aircraft does raise the question of whether something may have gone wrong on that side, perhaps involving the left engine. It's not a conclusion, just a question based upon observation. Even if there had been a left engine malfunction during one of the most critical times of flight, it's important to note that the Boeing 787 is designed to safely take off and climb on just one engine, even when fully loaded with passengers and fuel. A single engine failure alone should not bring a 787 down during takeoff. So if there was a loss of power, it may have been more complex or systemic. Another significant question is why the landing gear was never retracted. Under normal conditions, pilots will raise the gear within the first 7 to 10 seconds of becoming airborne. This aircraft remained airborne for about 30 seconds with the gear unretracted. There are a few possibilities. The pilots may have realized immediately after rotation that something was wrong and intentionally left the gear down. Or there could have been a mechanical issue preventing gear retraction. A gear retraction failure alone wouldn't necessarily cause a crash. But if that failure is tied to other system malfunctions, particularly those affecting thrust or lift, it becomes more relevant. Interestingly, in some decent footage, it appears that the RAT, or the ram air turbine, may have deployed. What is a RAT? The ram air turbine is a small deployable propeller that generates electrical and hydraulic power when needed in the event of a complete loss of onboard systems. It's essentially an emergency backup. So the Boeing 787 Dreamliner is equipped with a RAT, and its deployment, if it were deployed in this case, would suggest that there may have been a significant systems failure. If a gear issue and RAT deployment are connected, it could mean the aircraft lost primary systems very early in the flight. Third, let's talk a bit about lift. A plane generates lift through airflow over its wings. At takeoff, pilots configure the slats and the flaps, which are the leading and the trailing edge control surfaces, to tilt into the wind and maximize lift. If these were not deployed correctly, the aircraft would require a longer takeoff roll and may struggle to climb. This could explain the slow, almost labored ascent and the fact that the aircraft never gained significant altitude. Notably, the aircraft does not appear to fall out of the sky. It ascends, then descends gradually, suggesting some lift was generated, but not enough to remain airborne. In fact, the aircraft was descending so controllably that had there been a runway or some type of even surface available ahead of the aircraft as it was descending, it's possible the aircraft could have made an emergency landing, but unfortunately that wasn't the case. From the video footage and pictures we have seen, I cannot determine whether or not the slats and the flaps were deployed properly or enough to maintain lift or enough lift to keep the aircraft airborne. Further investigation will provide clarity on the wing configuration. The fourth question I have is how temperature at the time of the incident may have played a role in this crash. To explore that, let's look at the METAR for the airport at the time of the incident. METAR stands for Meteorological Aerodrome Report, which is a standardized weather report format used worldwide by pilots, dispatchers, and controllers. It provides real-time information about weather conditions at an airport. Now, for our purposes in this video, there's really only one number from the METAR that we need to pay attention to: 37. That's the temperature at the time of the crash. 37 Celsius, or about 98 degrees Fahrenheit, almost 99 degrees. That's extremely hot. And here's why that matters. Hotter air is less dense, which makes it more difficult for airplanes to generate lift. When air density decreases, wings have to work harder to create the same amount of lift, meaning the aircraft may need a longer takeoff roll and climb performance can suffer. So, if we combine that with any issues related to the wing configuration, which we've already discussed, let's say the flaps and the slats were not set correctly or properly, or some type of engine performance issue, then a lack of lift due to high temperature could definitely be a contributing factor along with other factors, which is what we potentially might be seeing in the footage. I'm not saying it was the cause, but it's an environmental factor that cannot be ignored, especially on a fully loaded Dreamliner taking off in nearly 100-degree heat. Now, reports indicate that a Mayday call was made. We don't know yet because we don't have access to the ATC recordings, so we don't know at what time during the 30-second flight this occurred, but there might be clues. A Mayday call is typically issued when a crew believes an outcome is likely catastrophic and immediate assistance is required. There's often a delay between recognizing a problem and transmitting a Mayday. Pilots will spend the initial moments trying to troubleshoot, so the crew likely identified a critical issue very early on, perhaps seconds, even before reaching the point when gear retraction would typically happen. That could explain why the gear stayed down. The aircraft was already in emergency mode. One final observation. While tragic, this crash was not a nosedive. The aircraft descends gradually, consistent with a partial loss of lift, but not a total aerodynamic failure. And amazingly, one passenger has survived at the time of this recording. Reports place him at or around row 11 near a forward exit. So his survival makes sense given that the descent of the aircraft resembled a forced landing more than a free fall. The gear was down, and he was likely close to an exit, able to escape before fire or smoke spread. So there's still a lot that we don't know, but because the 787 captures so much flight data, and because the plane remained mostly intact, and there are a number of video angles that have captured its ascent and descent, this is an incident that I am 100% confident we will get answers to. We don't yet have the ATC audio, and we may never get it publicly, but between the flight data recorders, the video footage, and eyewitness accounts, investigators will be able to pinpoint what went wrong.